So you're approaching your GCSEs at school and you're wondering what comes next. It's an exciting time, but you may also be feeling anxious, a little bit stressed, and possibly confused. If you're considering Suffolk 1 as your next step, then your first major choice is going to be between A-level subjects or a vocational set of subjects. A-levels are traditionally the familiar and recognized route to go to university. However, BTEC have a very viable alternative. The extended diploma at level 3 is regarded as equivalent to 3 STEM A-levels. This has the advantage of being able to allow progression to 3 distinct routes. At Suffolk 1, we've been delivering this engineering program for almost 10 years now. About a third of our students graduate and move on to full-time higher education, so that could be a university degree or perhaps a higher education college. About a third also choose to go straight into full-time work because depending on whether you graduate with a level 3 extended diploma in engineering or level 2 extended certificate in engineering, it is regarded as a qualification, which means you can enter work as, for example, a technician or a junior engineer. The last third tend to favor apprenticeships, so that's kind of an earn while you learn program. If you're level 2, you generally progress to a level 3 advanced apprenticeship, or if you are level 3, you generally advance to a higher apprenticeship. So why choose engineering? Well, some students choose engineering for a very simple reason. Amongst all the qualifications, engineering always tends to be amongst the highest paid. So sometimes it is all about the money. Others have done their research and they realize that there are major job shortages around engineering. The president of the Institute of Engineering and Technology, the IET, Professor Danielle George, recently did a short presentation showing a few of these opportunities.
Engineering and technology have been improving our world and shaping our future for centuries. From the music you listen to and the phone in your hand, to the clean water you drink and the innovations that are helping to restore our oceans. Engineering and technology are at the heart of everything. Engineers bring ideas to life, turn dreams into reality, and make solutions to big challenges possible. We want young people to know that whether they're into sports, music, fashion, flying, healthcare, or improving our climate, there is a place in engineering and technology for them. 1 in 5 people in the UK work in engineering, but it's no secret that we face a nationwide skills shortage. 203,000 people with engineering skills will be required each year to meet demand through to 2024. But it's estimated that there'll be an annual shortfall of 59,000 engineers and technicians to fill these roles. And that's just the stats for the UK.
The future is even brighter for girls and women in engineering, where there sadly is a major shortage, especially here in the UK compared to most of the world. There are loads of opportunities for events, conferences, awards, dinners, and activities focused on improving the number of girls and women interested and following a pathway in engineering and STEM subjects on the whole. There is no need to have previous experience in engineering, as everything is taught from fundamentals. However, a good grade and confidence perhaps in maths is essential, as we assume a basic competence at the start of the program. So a minimum of a 6 in maths, and 4 other GCSEs at 4 or preferably above, including English and a science or engineering subject. The course itself is a mix of enabling units. Those are units like maths, mechanical principles, electric principles, hydraulics, pneumatics and materials. And then application units. So those are ones where you use the enabling units to solve problems. So design and manufacture, or managing an engineering project, or continuous improvement techniques. And then there are some units that cover both aspects. So they take you from the fundamentals all the way through to how you apply them and solve problems, such as computer-aided drafting or CAD, and microcontrollers, where you use actual theory-based software simulations as well as the hardware in the kits. The course overall is roughly 70% theory and 30% practical activities. And those practical activities are a mix of things that could be computer-based or classroom-based and also workshop-based. There are 7 mandatory units and 8 optional units from various categories. So they're grouped in things like mechanical units or electrical units and thereof. And we choose these based on 2 factors really. The first factor is being what industry needs at this given time, and the other one is the experience and the knowledge of the staff members. We're quite fortunate as all of our teachers have worked out in industry, and we have a wealth of knowledge in the curriculum content as well as experience of what it takes to be successful out in the engineering workplace itself. Our aim really then is to equip students to hit the ground running when progressing from Suffolk 1. The timetable at Suffolk 1 is quite simple. There are 2 lessons a day, a morning and an afternoon one, which means over the course of a week there are 10 sessions available. Of the 10, 6 will be for your engineering subjects, 1 will be for a tutorial-based subject depending on which year you are in, and your lunchtime is quite a long one. It's an hour and a quarter currently, and within your program and your curriculum you will also have the time to do both independent study sessions, so where you can do your assignment work or homework if you like. Some students choose to also have a part-time job. You can use those sessions for them. Every lesson, if you require computers or laptops, they will be provided for those sessions. And if you are struggling with any subjects, we also run a variety of support sessions that can be timetabled in. Regarding assessment, there is a mix of assessments. Some are internally assessed and some are externally assessed. Of the externally assessed ones, 1 is what you would regard as a traditional exam, so a 2-hour paper where you sit down and you answer questions. The other 2 are more based around a portfolio that you do over the length of a week. And the internal assessments can also be made up of written work or practical observations, portfolios or presentations. At the college, we have quite a few service areas, so whether you need assistance with finance or transport, any student matters, careers guidance, there's a dedicated UCAS system, any progression issues, and even work experience, they are all dedicated areas to assist you in those regards. There are also a variety of other groups and clubs. These range from debating societies, strategy games, different types of sports like football, basketball, there's chess. Of course, these vary from year to year depending on student interest and student numbers. There's also a gym available for student and staff use.
Hi, my name is Ben Hagen. I'm the course coordinator for engineering, both the level 2s and level 3s. My main background is engineering materials and engineering mathematics. So, thank you.
Hi, I'm G. I'm one of the teachers on the engineering program. I was fortunate enough to be here right at the start, so we've been delivering this for quite a while now, almost 10 years. I teach quite a few units, both at level 2 and level 3. My background is mechanical engineering and a little bit of nuclear engineering as well. Although I have crossed over to quite a few different units now, including mechanical and electrical, as well as a few robotics units as well. Over the course of the program, all the teachers deliver different units, so sometimes it plays into our specialisms, and sometimes it's also quite interesting because there's a lot of debate and discussion brought in from the class as well.
My name is Piers Deshenyu. My qualifications, I've got I studied a BTEC higher in mechanical and production engineering, and I have a degree in mathematics. I don't have any A-levels. I went down the vocational BTEC route, but I do have GCSEs in maths and engineering, engineering drawing, building engineering, workshop theory and practice, physics, those sort of things.
Yeah, I'm Abdul Samba, one of the engineering teachers. I will be teaching you one of the units. So my specialist has been an engineering background, but mainly in hydraulics. So like this machine, which you will use it when it comes to one of the practicals.
Okay, so this is our biggest workshop, and this includes equipment for both metalwork and general engineering, as well as our 3D and 2D machining section. So if you come take a look around on this side, you can see we've got some basic metalworking machines, pillar drills, motorized stretch saws and so on that side. And as you come around on this side, all our workbenches over here. On the far side, lathe, milling machine, some more pillar drills. And then we've got a few of our thermal forming centers. This is including vacuum forming as well as extrusions. In this corner over here, we've got Cnc machines. So CNCs, we've got our 3D printers as well, and we've also got our laser cutter over here. Over the course of your program, you will be using many of these machines, and then also some extracurricular things. I won't give you any surprises yet, you'll have to come here and find out, but we've got our one racing initiative over here, where we've got an electric green power cart and a few others. We try and introduce some elements of robotics, so we've got a few of those bits of kit over here. It shows the evolution from the really old machines from the 60s and 70s up to very modern ones. Every room has got a classroom or a teaching area, so like this over here, they'll all have an interactive whiteboard so that you can do both written work in the classroom as well as practical work or activity-based work around as well. Some of our students' project work is laid out on the tables. When you do get into college, you'll be able to see some of those.
Yeah, Abdul Samba again. As mentioned earlier on, I'm one of the engineering teachers. This is one of the rooms that you will use for your teaching. Mainly, we use this room for theory teaching, such as mathematics, mechanical principles, and we have some equipment here. This equipment, you will use it for bending moment experiment. It's one of the very expensive equipment, but we are fortunate to have it, so you will use it in one of your practicals for Unit 27, which is mechanical principles and practices. And another equipment that we have here is this one of the bending moment equipment, but you can use it to test metal strength as well. Again, it's very expensive equipment, but we count ourselves as one of the luckiest colleges in the country, and we are able to afford it for you.
This room is the engineering lab, I would say, where we do the SolidWorks 3D designing. And then we have 3D printers, corners, 2 3D printers. And then we've got CNC micro CNCs, 4 of them, which we use for engineering, and we use that for our lessons, practical lessons as well. Thank you.
So this is our electronics workshop. As you can see, it's very well equipped, from basic components all the way through to modular ones that I'll show you in a second. Every desk we've got over here has got its own power supply, which means students can work independently as well as in groups and can share work with the teachers. The kits that you will use in year 13 of the program for microcontrollers. We use microcontrollers as tools to solve problems. We've got enough kits for an entire class to be able to work individually, which is very important in troubleshooting and getting the solutions.